Welcome back, student. Now today we'll discuss on critical properties. Choking in isentropic flow. Okay. In the previous lecture video, we'll discuss on one-dimensional steady isentropic flow. Okay. And in which we can already observe that if the value of m is equal to 1 or m less than equal to 1, m equal to 1 or m greater than is equal to 1, that m is basically Mach number. So m is basically Mach number. So what happens, and we derive the equation like dA by A is equal to dB by V in the bracket m square minus 1. So all these things already we covered, that what is nozzle, what is diffuser, okay, and we know that what is Mach number also. We already discussed all on various topic. Now we will discuss on the critical properties of choking in a isentropic flow. Okay, now as you know that mass flow rate of an ideal gas through a nozzle, is basically the flow is isentropic. Okay, the flow is isentropic. Now as you know that if the gas or fluid is flow within the particular channel, which is basically isentropic process, that flow is called isentropic flow. Now as you know that mass flow rate, as you know that discharge, okay, Q, as you know that Q is basically in your fluid mechanics part, Q is equal to rho into A into V, right? Rho into A into V. So mass flow rate of an ideal gas can also describe as m dot or q dot, both are same. So m dot is equal to rho into A into V. So mass flow rate, that is equal to rho into A into V. Now mass flow rate per unit area, that is equal to rho into V is equal to m dot by A, right? Now rho is equal to, we can also write, okay, in terms of rho basically, okay, so basically rho V is equal to, as you know, basically rho is equal to, we can write, as you know, rho is equal to 1 by V. Okay, so 1 by V is equal to P by RT, we can write here, because PV is equal to RT. So V is equal to RT by P, right? So 1 by V is equal to P by RT, right? So in terms of rho, we can write here P by RT into V. V is velocity. Now V, as you know that Mach number is basically the ratio between V by C. Okay, so V is equal to C into M. Now C is your basically velocity of sound or sonic velocity, and M is your Mach number. Now for a reversible adiabatic process or in isentropic process, you know that C also written as under root of gamma RT. Okay, under root of square root of basically gamma RT, which we already discussed on the previous lecture video, that we already calculate that C is equal to gamma RT. So this is basically C is equal to gamma RT. We already proved on that. So the topic was the velocity of sound in adiabatic process. Okay, now so you just introduce P0, as you know that P0 time basically introduce the stagnant property, stagnant pressure, that basically P by P0 is equal to P0 by RT. So P0 will cancel out, so ultimate equation that P by RT. So introduce here P0 here. Now in terms of that, if you calculate, if you just summarize on that, it will be possible that the expression becomes P by P0 is equal to, after that, under root of gamma by R is equal to P0 under root over T0 into T0 by T. Again here T0 are introduced here for stagnant properties, T0 by T into M. Now the expression becomes, after that, under root of gamma by R. So under root of gamma by R, again P0 by under root of T0 into P by P0 and into T0 by T into Mach number M, right? Now as you know, the relationship between the pressure and the Mach number, that stagnant property. So when you discuss on stagnant property, as you know that stagnant properties, stagnation state, basically stagnation state, we already proved that P0 by P, already stagnation pressure was, that expression was that P0 by P is equal to 1 plus gamma minus 1 by 2 into m square into the power gamma divided by gamma minus 1. So we already discussed on the previous lecture video. Go through it if you did not connect with that. So P0 by P is equal to, already know that 1 plus gamma minus 1 by 2 into m square to the power gamma by gamma minus 1. Again, and for temperature, as you know, the temperature is T0 by T. The stagnation of T0, T is static temperature, and is a stagnation temperature. T0 by T is equal to 1 plus gamma minus 1 by 2 into m square, right? So again, you can write here that T0 by T is equal to 1 plus gamma minus 1 by 2 into m square. Okay. Now m dot by A, that means mass flow rate per unit area, that equal to under root of gamma by R into P0 by under root of T0 into m. Now P by P0, as you know that 1 plus gamma minus 1 by 2 into m squared, so gamma by gamma minus 1 here, P by P0. Expression is P by P0, here it is P0 by P, so it will be reversed, so that will be here, minus will be coming here, so gamma by gamma minus 1 here minus is coming, that's why. So minus into minus gamma divided by gamma minus 1, okay, into, as you know that T0 by T is equal to 1 plus gamma minus 1 by 2 into m square, here it is under root, so it will be to the power half, so that's why it is, the equation becomes this one. Now m dot by A, the mass flow rate per unit area, that equals to, so m divided by these two terms, 1 plus gamma minus 1 by 2 into m square, is basically a same in both the cases, okay. So m divided by, if you in under denominator, so that will be, it is plus half, here minus, it will be minus half if it is goes to the in the denominator part. Now 1 plus gamma divided by gamma minus 1, so after all that will be gamma plus 1 divided by 2 into gamma minus 1. Now the expression becomes, so m divided by 1 plus gamma minus 1 by 2 into m square whole to the power gamma plus 1 divided by 2 into gamma minus 1, so that is coming here, okay. Now to get the maximum mass flow rate, we have to derive with respect to m, that Mach number, okay. If you derive the derivation, or if you differentiate, okay, if you differentiate this equation with respect to m, that after differentiation, or okay, after differentiation, that equation becomes under root of gamma by R into P0 into under root of T0, so mm, so it will be 1 here, so dm by dm, so that will be 1 here, that equation becomes same. Now this one is here, now this one, this term is same, now m is here, now derivation differentiation with this term, so dm by m, so this term will be this one, so minus like x to the power n here, so x to the power if it is n, okay, x to the power n, that means x to the power minus n if it is goes to the upward direction, so x to the power minus n, so minus n, so minus here, that's why minus, so this is the constant, so this three terms is constant. Now here x to the power minus n, if goes to the upward direction, x to the power minus n, that means minus into n, this term, into x, so this term, to the power n minus 1, so n minus 1 means this one minus 1, so that will be minus gamma minus plus 1 2 into gamma plus 1 minus 1, okay, into again that term is 1 plus gamma minus 1 by 2 into m square. If you differentiation with m, that will be gamma minus 1 by 2 into 2m. Now the equation becomes that under root of gamma by R, after calculation, after summation, after calculation, the expression becomes under root of gamma by r into p0 by under root of t0, 1 plus gamma minus 1 by 2 into m square to the power gamma plus 1 into 2 to the power gamma minus 1 into, so after all that will be cancel all this term. After that the equation becomes third bracket, second bracket, 1 minus m square to the power gamma minus 1 divided by 2 into 1 plus gamma minus 1 minus 2 into m square. You can try yourself, you will get this expression. So dm dot by means mass flow rate with differentiation, if you with respect to m, you can get this one. Okay, now for maximum value of this one, for maximum, to get the maximum value of maximum flow rate, to get the maximum value that it will be 0, that it will be equals to 0. Okay, now for this case is equal to 0. If you calculate, you can get from this expression m is equal to 1. Okay, m is equal to 1 means m is equal to 1, that means v is equal to c, that means it's a what? Sonic velocity, right? V is equal to c, m is equal to 1 means what? Sonic velocity. So for if m is equal to 1, that means in particular region, in a particular section, in a particular region, you can get, sorry, okay, you can get, so the discharge is maximum when value of m is equal to 1. Okay, and as you know that m is equal to v by c and v is equal to, so c into m, and you know velocity of sound for a particular adiabatic process, c is equal to under root of gamma t into m. Now by logarithm differentiation, that log v is equal to log of m into under root of gamma t, that will become that log v is equal to dv by dv, dv by v is equal to dm by m plus half into dt by t. Okay, half into dt by t. So dv by v is equal to this one. Now as you know that stagnation properties for temperature stagnation property T by T0 is equal to 1 plus gamma minus 1 by 2 m square minus 1 to the power minus 1, because as you know that temperature stagnation property relations is that T0 by T is equal to 1 plus gamma minus 1 by 2 into m square. Okay, here it is T by T0. In this expression T0 by T, okay, we will prove that T0 by T is equal to 1 plus gamma minus 1 by 2 into m square. Here it is T by T0. We know that 1 plus gamma minus 1 by 2 into m square to the power minus 1. Now if you by logarithm differentiation, you can get possible that dt by d is equal to this one. Okay, dt by d is equal to this one. If you get a differential logarithm, if you get the logarithm differentiation, you can get this one, this value. Now similarly, you know the value of dt by t here, you know the value of the, so from equation 1 and 2, from equation 1 and 2, you can easily possible that dv by v is equal to dv by v is equal to dv by v is equal to 1 plus, sorry, dv by v is equal to 1 plus gamma 1 divided by gamma minus 1 by 2 m square into dm by m, from equation 1 and from equation 2. It can possible that you can calculate dv by v is equal to this term. Okay, now dv by v is equal to this one, and you know that the expression is that dA by v, dA by a is equal to dA by a, from the previous expression. For we already proved that this expression, that for one-dimensional steady incompressible isentropic flow, for one-dimensional steady isentropic flow, that we already proved that dA by a is equal to dB by v into m square minus 1. Okay, so dA by a is equal to dA by a is equal to m square minus 1 into dB by v. Now here it is dB by v is equal to dm by m plus half into dt by t. So after all, the dA by a is equal to m square minus 1 into dB by v. So dB by v is equal to 1 plus gamma minus 1 by 2 into m square into dm by m. So you can put this here. Okay, in terms of dA by a, expression was m square minus 1 into dm after calculating all this m square minus 1 into dm into divided by m into 1 plus gamma minus 1 divided by 2 m square. Okay, if you now, as you know that so this is the one expression, dA by A is equal to m square minus 1 into dm into m into 1 plus gamma minus 1 by 2 into m square. It is one expression. Similarly, you already proved that dA by A is equal to this one. It is also proved in case of one-dimensional steady isentropic flow. You already proved that dA by A is equal to, in the previous lecture video, dA by A is equal to this expression. Similar fashion, you can write also dA by A is equal to dB by V into m square minus 1. Okay, we already proved this one. So dA by A we can write in the previous lecture video, in the previous topic, dA by A is equal to dA by A is equal to these equations. Now, in all the cases, if you substitute the value of m is equal to 1, because of we already proved that if the value of m is equal to, if the value is m is equal to 1, then it can only possible that mass flow rate is maximum, because we know that we already studied the critical properties are choked in a particular isentropic flow. So for choked flow, or for critical properties choked in isentropic flow, that particular type of flow in which the flow or discharge will be maximum for a particular location. Okay, now if the value of m is equal to 1 here, if the value of m is equal to 1, that means this one. Okay, dA by V is equal to this one. Now if you put this value here, m is equal to 1, so dA by A is equal to 0. That means A is equal to constant. Similar fashion, if you put this value m is equal to 1, that means this equation becomes 0. So dA is equal to 0, A is equal to constant. Similar fashion, if you put this value m is equal to 1, that means dA by A is equal to 0, A is equal to constant. So all these expressions, in all these expressions, if value of m is equal to 1, if you put here, then you can get A is equal to constant for a particular, only at the, it is possible only at the throat section. Okay, only at the throat section. So m is equal to 1 occurs only at the throat and nowhere else, and this happens only when discharge is maximum. So for a particular when the fluid is flow through a particular convergent divergent nozzle, and you know that convergent and divergent nozzle, and in a throat is basically the maximum smallest diameter of the particular duct, that is basically throat section, and in this particular channel or in this particular section, the flow rate is maximum or discharge is maximum, and here the area is constant. Okay, so for m is equal to 1 is satisfied only at the throat section. Again, now if the convergent divergent duct as a duct act as a nozzle, okay, now as you know that convergent divergent duct, it may be sometimes nozzle, it may be sometimes diffuser, depending on that. If the convergent divergent duct as a nozzle, in the divergent part, also the pressure will fall, as you know that diffuser, and in the divergent part, so you know that this is the divergent. So this is the convergent channel, this is the throat section, this is the diverging channel. Now in a convergent divergent duct as a nozzle, in the divergent part also the pressure will fall continuously. Okay, the pressure will falls continuously to yield a continuous rise in velocity, because in case of divergent is, as you know that in this section, when the fluid is flow through this channel, when the fluid passing through this area, the pressure will be decreased. Okay, pressure will be fall continuously, and to increase the continuous, again it corresponding velocity will be increased sufficiently when the fluid is flow through in a divergent channel. Now the velocity of the gas is basically subsonic before the throat. When the velocity of the gas is subsonic before the throat, becomes sonic at the throat, because as you know that for the condition subsonic, if m value is less than 1, if m value is less than 1, that means m is equal to v by c, that is equal to less, so v less than c, obviously for subsonic case. And if m is equal to 1, it happens m less than equal to 1 to m is equal to 1 from when the fluid is flow through this section to this section. Here m is equal to 1 and m is equal to 1. Okay, now basically the velocity of the gas is subsonic before the throat and becomes sonic at the throat and then becomes supersonic till it expands in isentropic flow, because when the fluid is passing through the divergent channel, the velocity is basically increased. If the velocity increase in such a way that it can reach or it can goes to the beyond of greater than value of c, means sonic velocity, then the fluid velocity is called supersonic velocity. So in this case it is possible. Okay, now, and the reverse condition prevails when the inlet velocity is supersonic. Now in this case we already discussed that in this case we assume that the fluid velocity is basically subsonic. Now if it is happens so that the inlet condition of a particular converged divergent channel is basically supersonic, now what happens here? Now it's basically the whole duct basically then becomes a diffuser. A whole duct then becomes a particular diffuser, and this transition from subsonic flow to supersonic flow and can occur only when the compressible fluid flow through a particular throat and exit pressure is maintained at appropriate value. Okay, and so basically what happens here, so if you put this value m is equal to 1, if you put this value m is equal to 1, now discharge is basically maximum and the nozzle is said to be choked, okay, at particular condition. So this basically critical properties are basically defined with designated with basically subscript asterisk, actually subscript asterisk, and this is basically T0. So Ta star basically here asterisk terms, so asterisk, so it is basically defined with asterisk terms. So T0 by T, as you know that the relationship for stagnation property T0 by T, now T is becomes T star or asterisk terms here, 1 plus gamma minus 1 by 2 into m square. And now if you put this value m is equal to 1, the expression was that T0 by T asterisk is equal to gamma plus 1 by 2. Now if you reverse this T asterisk by T0, that will be 2 by gamma minus 1 plus 1. Similarly for critical pressure ratio, and you know that P by P0 equals to the relationship between the stagnation property. Now P by P0, as you know that P by P0 is equal to 1 plus gamma minus, so this is the expression for stagnation property. Now P0 by P is equal to 1 plus gamma minus 1 by 2 into m square. Okay, now for critical pressure ratio, if put these values P in terms of P asterisk, so that becomes basically, so if you P0 by P here, P0 by P is equal to 1 plus gamma minus 1 by 2 into m square. If you put this value m is equal to 1, the expression becomes 1 plus gamma minus 1 by 2. Okay, now if you put these values here in terms of P here, just in terms of P here, P star, so if you reverse this, so after all you can get 2 divided by gamma plus 1 to the power gamma minus gamma 1. Okay, now for diatomic gas, as you know, for diatomic gas gamma is equal to 1.4, and as you know for diatomic gas gamma is equal to 1.4. If you put these values in that particular expression, so it will becomes that P0 by P star, P asterisk divided by P0 is equal to 0.528 for air. Okay, for superheated steam gamma is equal to, as you know that gamma value is 1.3. The expression was P star by P0 will be 0.5046. If you put these values in terms of gamma is equal to 1.3, that will give that 0.546. Similarly for air also, T star by T asterisk by T0, that will be 0.833, and similarly for density also 0.634. Okay, now by substituting the m is equal to 1, okay, so if you put these values, if you put this expression in terms of m star by a, okay, now here if the value is converted into in choke critical properties, if it happens so a is equal to s a asterisk, the equation becomes, because it happens so when m is equal to 1, now you know that expression is m dot by a is equal to this one, so if you put these values, all these terms in m is equal to 1, so the equation becomes so this one. Okay, you just try yourself, then you can find your expression, otherwise you cannot. So expression becomes this one. Now dividing equation 5 and 4, so suppose this equation becomes 5, and if in this expression the expression is 4, okay, so this is the first expression in critical properties choking in isentropic flow, then you can calculate a by a asterisk, that is becomes equation becomes this one. Okay, so this is called basically area ratio. Now when you draw the plot, or when you draw the diagram of a by a stick with versus m, and when m value is reaches with value of 1, then the basically that subsonic basically nozzle, and when it is reaches with, when it in this diagram basically in this plot, it is described as the value of which shows that a basically subsonic nozzle is converging and a supersonic nozzle is diverging. Okay, now in the next lecture video we'll discuss on the dimensionless velocity, like m's asterisk, like Mach number in terms of Mach number, pressure distribution, and choking in a nozzle. Okay, thank you very much for listening and watching me, and goodbye.